This week we have learned about strain engineering more deeply, scaling down, and quantum tunneling. First, I would like to review about strain engineering. Before I cover up the strain engineering, we must know the two types of the forces. One is the stress, and which is the inside force per unit area, and the other is strain, which is the amount of deformation. For strain techniques, there are two kinds of strain techniques, as you can see in this diagram, which are global strain and local strain. Global strain is a method of give force to whole of wafer, and local strain is a method of give force to each individual devices. There are some problems with global strain. Expensive wafer and many defects, mainly about state. They could occur frequently when trapping electrons. And other problems are self-heating problems such as SSDOI and SSGOI, which could not transfer devices heat to below the silicon substrate after annealing. And last problem is it could only use one type of strain. And next, SMT is an derivation of stress memorization technique. As you can see in this diagram, there exists a crystalline defect in the position of source and drain here and here, and each role is to memorize each strain. But it also has defect as well. Due to each defect, each duration is short and each contact resistance could increase and it could occur short. And for next chapter, there are two kinds of scaling down by using constant field and constant voltage. But nowadays, technique of constant voltage has some problems, so we usually use constant field technique instead of constant voltage technique. And for quantum tunneling, there are two kinds of tunneling. One is direct tunneling, which we also call it as DT for each abbreviation. For each concept, the electrons tunnel through the whole silicon oxide energy barrier, as you can see in this band diagram. Other kind is Fowler-Nordheim tunneling, which we could also call FN tunneling. For each concept, the electrons from p-type silicon tunnel through a part of the barrier to the conduction band of the insulator. From there, it can flow to anode, but both have problems with leakage current and power consumption. And this is about the gate leakage in here, and we're gonna talk this about later. And thank you for listening.